That means it's supposed to be recording. Let's just check.
Will it hear our voice?
Is it working?
No.
Oh yeah, it's working. You can see the little green light is going up, so it's working.
Why won't it hear my voice?
You're too far.
It probably won't. It'll be like, you'll sound like the grown-ups on Charlie Brown. Wah, 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 wah. You know how I normally sound to you guys, right? Like Maddie's been in my class before. That whole lecture about being late, all she heard was wah, 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 wah.
The guy from Sesame Street?
What?
Oh, the Muppets. That's the one. The Muppets. Oh, yeah. Yeah.
Which Muppet? Oh, the Swedish Chef. Do you want to know something about the Swedish Chef? Let me tell you something about the Swedish Chef. You know how the Swedish Chef has real hands? Right? If you look at the Swedish Chef, he's got real hands. That's one guy, but then it's another guy that does his body. It's two separate dudes. And they never worked together. So the guy doing the hand stuff, the guy doing the borgy, never had any, it wasn't in the script. The hand stuff is all improv. And the borgy guy has to work with that.
That's cool.
I know, it's crazy. No, it's not all he says. If you watch the Swedish Chef, he does not only go bork, bork, bork. He talks, especially on the new ones. The new Muppets are so funny. If you haven't been watching the newest Muppet show, you should do yourself a favor.
Muppets 1.
No, it's on regular TV.
Okay, yeah.
It's kind of like the Muppets as 30 Rock. It's really good. All right, so here we go. So, remember, the first thing we're going to deal with is, I would like to remind you, what is a rational number?
A number that's rational?
You weren't here yesterday. It's got to be a ratio, right? So it is every fraction.
Okay. Even though
Every whole number.
Where's the fraction again?
And decimals that do what?
The end to repeat.
Decimals that end or repeat.
Wait,
So just to remind you.
decimals can do other things than end or repeat?
Yes, like pi, 3.1415967, and so on for billions and billions of decimal places. Yes. Pass those back. All right. So, I want you guys to add these up. We're going to go ahead and start working on it. Now, obviously in math, in the real world, you would never add this in any way except using a calculator, correct? Like, you absolutely but, Omar, I'm well aware you can. The point I am trying to make is you wouldn't. You would use a calculator, okay? But I want to make sure you're aware of what is going on, because everybody says, Mr. Myers, we can add and subtract. But I've been teaching grade 9 for 17 years. I've been putting addition and subtraction questions on tests for 17 years. And kids aren't getting 100% on them. Okay? So adding and subtracting is not as easy as everybody seems to think it is. All right? So, first of all, if you were going to do that on your calculator, what would you push?
You push the negative.
Tell me the buttons you would push. You don't have to write anything down. Just tell me what you would push.
Negative button, then you push 2.3, and then you push the plus button, and then push the negative button, and then push the 1.
Yeah, see what I mean? When it's written, everyone gets confused because you know somebody in your math history, Hayden, said, no, you do your brackets first. There's no math in those brackets. Why are those brackets there? Emily? Yeah, because this is addition. It's a math operation, isn't it? This is a negative sign, which just tells me a certain spot on the number line. Everybody understand?
Yeah.
Oh, I get it.
Okay. So first thing we're going to talk about what that means. That's a math operation. Okay? And all the math operations do is move
Your little decimal
you along
line.
the line. That's all it means. They're going to move you along the line. Now, negative signs and positive signs, what do they tell you?
They tell you.
Pardon me? The direction, right? And where does every number line start? 0. Everybody cool?
Yeah.
All right. So this question is telling us, technically, 0 is out here, isn't it? Because every math question starts at 0. But we don't write 0, do we?
It's only
Because math guys are lazy.
yeah.
So the first thing I do is go to 0, and then I go negative 2.3 steps. Which is what direction, James?
Negative 2.3 is that way.
Is left.
Yes.
Correct?
Yeah.
So now I've put it here for us. 2.3. How did I know it was 2.3? Well, the line is split into 10 chunks. 10 chunks are decimals. So 3 decimals is 3 steps. Cool?
Yeah.
Okay, so the plus sign says we are going to then move along the number line. And then the negative sign tells us in what direction. What direction is it? Left. 1.9. Correct? So 1.9, how many little steps is 1 when we're counting with decimals? How many dimes are there in a dollar? 10. I got to go 1.9 steps, don't I? So that's 10 for the 1, and then 9 more. It's 19 steps, right? So would it be okay if I went 1, 2, 3, 4, 19 times?
Yeah.
Would I get to where I'm supposed to be?
Yes.
And that's okay, isn't it?
Some people do that.
Some people do, and that's okay.
Yeah.
Because this is an elementary school. I don't care how you do it. The way I would do this is say, okay, well, I know I need to go 19 steps, don't I?
So I knew
And I know 10 steps is 1, correct? So I'm going to go to 3.3. That's covering 10 steps, right? And then 10 more steps would take me out to 4.3, right?
so you should
But I don't want to go 10. I want to go
9.
9.
So
So
you
I would stop right there. And there's my answer. What is it? What kind of 4.2? Negative, because I kept going left. Everybody got it?
Yep.
That's it. Now, of course, on your calculator, you're going to go negative 2.3 plus negative 1.9 equals, and get negative 4.2, aren't you?
Yep.
Right? That's what you're going to do on your calculator.
Yep.
But I can train a monkey to do that on the calculator. But I can't train a monkey to explain why it works. And that, ladies and gentlemen, up until now, you have been doing math just to get an answer. From grade 9 to grade 12, we spend a lot more time saying why things work. Everybody understand?
Yep.
Okay, so let's look at the next one. Fractions. Barf. Nobody likes fractions. So when you look at that, you're like, oh God, common denominator, I don't know. What do I do? But that's another strategy. Why? You give me away. I was just about to say, what are some strategies you guys have for dealing with this? So Hayden says, I'm going to make it a decimal. Then it's really easy on the calculator, right? That's cool. That's okay. Or you can common denominator it. That's cool. That's okay. Or, because like I said at the beginning of it all, isn't math always the same?
Can't we just count?
Yeah. If one thing works once in math, won't it always work?
Yeah.
So if decimals work on a number line and numbers work on a number line, will fractions work on a number line?
Yeah.
Of course they will. Now look, I've helped you out. I start at negative 1/2. Where did I really start, but we're too lazy to write it down?
Negative 3/4. Wait, negative half. Two quarters.
Karina, say it louder because James is going crazy up here. You always start at 0.
Yeah.
Right?
Oh, 0.
Okay? So then
I thought you were talking.
I put my first dot at negative 1/2. Now I already put it there for you guys. Because the question is saying go in the negative direction 1/2. Now I look at this. What are these fractions divided into?
Yeah.
5?
Four.
1, 2, 3, 4. These are fourths, aren't they?
Yeah.
So I need to look at each question and decide what the fraction is. So if that's 1/4, that's 2/4. 1/2, what's this? 3/4. And once you've done that, you're set. Because it's math and it's a pattern and it will be all the same. Everyone cool? So this question is saying negative 1/2 and then I got to go negative 5/4 more. So we got 2 ways to do it. We can count 5 steps, can't we? In which direction?
That way.
Left. 1, 2, 3, 4, 5. Oh, and here I am at the answer that I've already given you. Okay? Now, remember when I said at the beginning of the year, 3 days ago, that you guys will often punch stuff into your calculator and you'll write down what your calculator says, even if it makes no sense, right? This is one of the worst questions for you guys, because you guys have little facts floating around in your head. Like Hayden said, do the brackets first, as soon as he saw brackets, right? And that's normally right. But then he took 2 seconds, even before I could say anything. It's like, oh, no. There's no math. I don't know, Mr. Myers, right? Same thing here. A lot of you guys will see, oh, two negatives makes a positive. How many of you thought that for even 1 second?
Me.
Right? But you can quite plainly see it didn't. Because what does this question say in English? What does that negative tell us? It's going left, right? Left, right. It's going left, correct?
Yes.
That's what that negative tells us. And then it's going more left. So the answer has to be negative, right?
Because it's not.
Now, if you punch that wrong into your calculator and you get a positive number and you write it down, that doesn't make any sense, does it? And if you stop and think about it for a sec, wait a minute, it's negative and then it's more negative. It has to be negative. So the point I'm trying to make here is before you even go to your calculator, before you ever do the question, just stop and think for a sec. Right? It's negative and then more negative. I'm going to end up negative. Right? Or the other way around. Cool? Okay. Now this, ladies and gentlemen, is something that is very sexy in math right now. Okay? This is something that the people that don't teach math but wish they were awesome enough to teach math, this is what they like to see. And this is what we call adding pictorially. Because you're using a picture to do the numbers. Okay? So let's have a look at these two. You guys give them a shot. There's the number line.
Mr. Mayor, I have a question for 1A.
Yeah.
For the negative 4.5 and positive 2.3,
Mm-hmm.
do you add the 5 with the 3 or minus the 5 from the 3?
Okay. I understand what you're asking, Xavier. But when you use the number line, you'll see how it works. Okay? So where does this start? It always starts at 0. We forget about 0. So we need to go all the way to the left, 4.5, right? Now you've counted this. You know this is broken into chunks of 10, right? So 4.5, there's negative 4, and then 1, 2, 3, 4, 5. We're here, right?
Yeah.
Now what does that mean?
We're up down.
We're gonna do something else.
Yeah.
We're gonna move along the number line. Now, what sign should be right there that we don't write because we're lazy math guys?
Negative.
0.
Not 0.
No.
Every number. What is that, a positive or a negative number? Positive. We don't write the plus, do we? Because math guys are lazy. So what is the direction that's happening right here? So we're going to go, this is saying it's positive,
But positive and negative.
which means we are going to go left 4.5 steps, and then positive right
2.5.
2.3. Okay? So 10 steps is 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 1. Oh, thank you so much. And then 10 more steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. There's 2. And then 3. 1, 2, 3.
There's some lag.
And what's the answer? Negative 2.2.
Can I borrow a pencil?
Understand?
I only have this one pencil.
Second time, but I wrote 2.
Yeah. Pencil. I just had one. There. Cool?
Yeah.
Now, this one's fractions. Now let's stop and think for a second. I'm going in the negative direction, and then I'm going more in the negative direction. So what's the only direction the arrows are going to go on this number line?
That way.
Left, left, left. Correct?
Yep.
So, 1/3. What have I split it into? How many? Threes, right? So 1/3 is one step. So I'm starting right here because I went left 1/3. Does everyone agree?
Yeah.
Everyone cool?
Yeah.
And then left 7 more. 1, 2, 3, 4, 5, 6, 7. So now how would I write this to show me work? You would say negative 1/3 right there. And then this is the negative 7/3. And then this is our answer, which is what? Negative 2 and 2/3. Cool? That's adding with a picture. All right?
Which is some of the easiest.
Some people really like this. Some people can make this work with all fractions.
Yeah.
Yeah, some people dig it. And that's cool. I'm okay with that. If you want to use that, you're perfectly allowed.
I agree.
Let's turn the next page. Oh. Now this one's a little snakier. Why?
Because
What makes C hard?
it moves forward then backwards.
It moves forward and backwards? What were you going to say, Xavier?
I was gonna say to reverse the
Backwards
positive
and
and
forwards
the
and backwards.
negative.
Yeah, so the forward and backwards thing, left and right. It's got 2 different directions. Was that what you were going to say, Emily? The denominators are different, aren't they? Now let's check our number line. Does our number line work with one of those denominators? Which one, Cassidy? 8. This is split into 8s, isn't it? Now you guys are smart kids. 8s and 4s already work together, don't they?
Yep. They're equal. Whatchamacallit?
They're equivalent fractions because 2/8 is 1/4, correct? So if this is 1/8, this is what?
2/8.
2/8, which is also
An equivalent fraction.
1/4, correct?
Yeah.
And then this would be what? 3/8. And then this would be what?
2/4.
2/4, which is also
An equivalent fraction.
a smaller 1/2.
Oh,
Picking up what I'm putting down?
we're trying to put into it as well.
Everybody with me? So where are we going to start? We got to start at positive 3/8, which we just put on here, right? Right there. So the first thing we did was this. So to show me work, you're going to do positive 3/8. Agreed?
Mm-hmm.
Everyone's cool with that step? Now I got to go negative 3/4.
Which is
Well, I know that a fourth is 2 steps on here, don't I? So I got to go 3 steps of 2, right?
yeah. Which is
So I'm going to change colors to make it easier for you guys. I'm going to go back 1. There's one of my steps. 2, 3.
Wait, why are we skipping 2 of them?
Because I got to go 3 of those quarters.
Oh, yeah.
Cool? So in red, I've gone minus 3/4. And then my answer lives right here because it's where I ended up. Now what is that? There's 0. How many steps am I to the left of 0? 3. And each step is worth what? 1/8. And I've got 3 of them. And am I left or right of 0?
Negative.
So it's negative
3/8.
3, because that's the spot we are in the number line, over, what have we chopped the line into? 8s. And all of a sudden you're adding fractions without ever doing common denominators or anything. Right? Because common denominators is what messes everyone up. Now, of course, what do we have to do right now? After we're finished with the pictures, what do we got to do right now?
oh,
We got to do it without the number line. Now we got to do it with the way you were taught in the past. So let's have a look at that question. And before we go any further, let's just think for a sec. If I gave you guys this, how many circles did I just draw? 1. And then I drew that, and I added it. What would the answer be?
2.
2 circles. Stupid, right? Everybody can do that. Okay. Now if I give you this,
1 circle. Well, wait, that's a quarter of a circle. Did it?
what's that?
A quarter of a circle.
A quarter of a circle, right?
Big quarter.
And then I add that, What have I got? I have a half because that first quarter and that second quarter gets me to a half. Everybody's comfortable with that, yeah? The problem with math is we can cut that pizza into any size slice, can't I?
You can cut it in.
Now, if we call it slices, and I say, I had one slice of pizza.
It'd be a pie.
Everybody with me?
Yeah.
I had one slice. It's a quarter of the pizza. And then I have another pizza over here, and I cut it into 8, and I give one slice
To Jerry.
to Xavier. I had one slice, he had one slice. Even Steven, right? He owes me for half the pizza because he had a slice and I had a slice. Right? We spent $20 on pizza, he owes me $10. So we both got one slice. Doesn't work, does it?
No.
Because that's all fractions are. They're slices of whole numbers, aren't they? So as long as they're the same slice, then we'd have a deal, wouldn't we? You'd give me my $10 because we had the same amount. But you did not get the same slice of the pie. And all a fraction is a different slice of the number. So we look at these, and I see that this guy is slicing my numbers into how big a piece? 5s. This guy is slicing my numbers in 2. Is that a fair deal?
No?
No.
No? No.
No. Because if I take one slice, I'm getting half the circle. And if I give you one slice, Sash, you're only getting
Oh.
that much of the circle.
But I'm on a diet.
Like, I'm on a diet. No.
So we can't do this, can we? All right. So this are different slices.
Meaning you want to make them equal.
Right. Which means they need to be the same.
So you have to do.
Now, how do you make them the same?
You have to do like adding.
No,
and then
you always get to say it. Karina's going to say it.
Okay.
You got to find a common denominator. Everybody knows the words, right? How do you do that? What allows you to change? Why is it multiply? See? Somebody taught you that it was multiply. You multiply. But why? Yeah, you can multiply or divide. Good call. Everybody forgets the divide one. Everybody wants to say multiply.
Because if you divide, then you go down.
Yes. But why does multiplying work?
Because multiplying is.
What if I split that circle into? Fourths.
Multiplying.
Right? Everyone agree?
Multiplying is cutting it more.
Okay, so now I'm going to multiply it by 2. So now I'm cutting it into 8. Cool?
So you keep cutting it.
So-
more you times it.
There's my quarter. But how many eighths is it? 2. So I had 1 quarter and 2 eighths. And you can see they're exactly the same, right?
And then you could go to.
So they're the exact same thing, aren't they?
Yes. That's the
So
lowest.
I did times what to get to 2? 2. And if I multiplied the numerator, I got to do the same thing to his partner, right?
Yeah.
Because they're locked in.
Yeah.
So I got to multiply him by 2. And then I'm done. So let's come to here. I got to have the same slice of pie. Now the question always comes up, how do you know what size to go to?
You can keep going until you feel like you.
Well,
So
the
you-
way I was taught was you take the bigger number, and you write out a bunch of them. 5, 10, 15, 20.
Or you're smart, you got
And then you take the littler number, and you write out a bunch of them. 2, 4, 6, 8, 10. And there's your match. How many of you were taught something like that at some point?
Yes.
All of you were, right? Which is a super pain in the ass when the numbers get big, isn't it?
Smart.
Yes.
It's like 100.
5.
Oh, yeah, you guys always give me a hard time about my 5s.
There
There.
you go.
Okay, sorry. I can't wait to mark your first piece of work. I'm sorry, Xavier, this is wrong. This does not look like a 7. Mhm.
Okay, I'm pretty new. Alright.
Hey, we'll see. All right, everybody cool? That you guys have all seen that, right?
All right.
Now,
Great.
can you see a shortcut to getting to 10 when you have 2 and 5?
Yes.
What is it?
You got like so 2 times 5 is 5.
2 times 5 and 5 times 2 are both 10, aren't they?
Yeah.
So does that tell you how to find a common denominator?
Once
Yes.
you do that, once you do the bottom, you go to the top.
Yeah. So if I know I'm doing 5 times 2, I know I'm going to have 10 on the bottom for both of them, aren't I? What did I do to 5 to get it to 10? Times 2. So what do I got to do to 2? To get 4. Now the whole thing was negative, so I keep the negative.
So if you just times it by itself, it usually gives the
It
correct.
always gives you a common denominator.
Doesn't mean
It isn't always the lowest,
Yeah.
but it will allow you to do the work. Because
Yeah.
one of the biggest problems kids have with finding common denominators, they sit there, what's the lowest common denominator? It's got to be the lowest common denominator. I need the lowest. You don't. You just need a common denominator.
The lowest just helps you make it easier.
Yes.
Ta-da.
But if you can't do it at all, James,
Yeah.
then you're screwed, right? So this will always allow you to do something. It'll get you halfway to the answer. Actually, in the real world, it's the real answer.
Thanks for the hint.
Okay?
What? Illuminati confirmed.
Not really. But 1/4 is 2/8, isn't it? But I know you guys, your elementary school teachers would have marked that wrong, wouldn't they? And not in lowest terms. Right? Without actually thinking about it. Lowest terms. What does the word low mean? Small.
Large.
Right, as low as you can go. Right? Is it changing? Isn't 47 over 94 just still a half? So has it really changed in value? Has it reduced? Which is what everyone says, reduce your fractions. Are you reducing them?
No.
No, they're the exact same fraction, aren't they? So really, when someone says, put your fraction in simplest form, are they testing your knowledge of fractions or are they testing your knowledge of division? Division, which is grade 3. Picking up what I'm putting down? So to mark you wrong for something when you've done all this work and then you've forgot grade 3 division, that doesn't sit well with me. Xavier.
I learned division in grade 4.
Okay.
Whatever, no one cares.
I'm a big liar.
That was the
So what was this? What did we do to 2? Times 5. So what do we do to 1?
Times 5.
Times 5. So it's a nice one for Xavier. And it's 5 over 10. So now what do I have? I have negative 4. Right? Plus
Okay, good.
negative 5. And they're both over what now?
10.
10. What's negative 4 plus negative 5?
9.
Negative 9 over 10. And all of a sudden we're adding fractions. Okay?
But they're still negative, so wouldn't they make a positive?
We just talked about that.
So they
Not
don't.
always.
No.
It's just going farther down the line.
This question is saying, Tasha, go to a negative spot on the number line and then go more negative.
Oh, it's without. Oh,
Picking up what I'm putting down?
yeah, I get it now.
Okay, so let's look at the next one. 12 and 6.
3/4.
Can I do 6 times 12? I could, but then I've got a really big number. Now I told you to always use that.
6 by 2 and 12 by 1,
Yes,
which I already did.
always check if they work together small. Right? 2 and 5, you could see, weren't going to work together, but 6 and 12 do. Our common denominator is 12. So since it's 12, do I need to change 12?
No.
Of course not. I only changed the 6. How do I get 6 to 12? 2. So what do I got to do to the top one?
2.
So that is 2 over 12. So I have negative 7 plus 2 over 12. So now I'm down at negative 7. And then what direction am I going here? Back to the right. How many steps? 2. So I'm at negative 7. Now I'm going to the right. Negative 6. Negative 5. So I'm at negative 5/12.
Can I go to the wall?
Yes.
I had to go to the
You'll be able to in a moment. So what about this guy? What's my common denominator? 3 and 5 don't work together. And 3 doesn't hit 5 early. So now I should do what? What's the trick I just showed you? You said it, Karina. I heard you.
Denominator was 15.
15. So I know I need 15 on both of them. So now I just got to decide, what did I multiply to get to 15? What is it? Times 3 times 3. So what's this guy?
Negative.
Not negative.
Negative 1 over 5.
3 times 3 is 9. And here, you've already got to the answer, Hayden, you cheating dog. What did I multiply 3 to get 5? 5. So what do I multiply the top by? What's 2 times 5? Now, what have I forgotten here that all of you are going to forget on? The negative sign. So now, everything is over 15, correct? So do I even care? Do I need the 15? Because everything's going to be over 15, right? So really all I'm doing is adding 9 and negative 10, aren't I? What is 9 minus 10? Negative 1. And I know that it's over what number? 15, because Hayden already gave us away. That's okay, Hayden. You can be the best. We'll let it go.
Thank you. I'm probably not. I guarantee it's like these people.
All right. Now, guys, this mixed numbers make it difficult. Okay? Now, listen to me closely. There's 2 ways of dealing with mixed numbers. All right? One of them is to make them an improper fraction. And the other one is to deal with the numbers and the fractions separately. Okay? I deal with the numbers and the fractions separately. You guys probably want to make these improper fractions. I don't care which way you do it. We're going to do both. Okay? I am betting that most of you guys, when you see this, you want to turn them into improper fractions. Is that correct?
We're not allowed doing that?
No, you are.
Oh, I already did it.
Hayden. So this is negative 2 and 1/8. So how do I make that an improper
2
fraction?
times 8 plus 1.
Times plus, right? So this guy is negative 17 over 8. Agreed?
Yes.
Okay. And what's the other one?
Plus 10 over 3.
3 and 1/3 times plus 10 over 3. Cool?
Yeah.
So what I really have is negative 17 over 8. Agreed?
Yep.
Plus 10 over 3. Yeah? Everyone, we haven't left anyone behind, have we? Okay. So what's my common denominator? Because those are different slices.
Times 8 by 1 and 3 by
8 and 3 won't work together. So as soon as 8 and 3 don't work together, and 6 and 8 don't work together, and 16 and 3 don't work together, what's our shortcut? What's our quick move?
This times it by each other.
Times it by each other. So I'm going to be over 24, aren't I?
Yeah.
Now, this guy, now watch what you get to do. Now that we've done a bunch of work, just take that 3 up there and that 8 up there. It's not really cross-multiplying, but teachers will call it that. It's not really. Cross-multiplying is something different that we will do this year. So 17 times 3. Can you do that in your head?
No.
Some of you won't be able to. Are you allowed to use your calculator?
Yeah.
Now, this is a perfect example of when I say, don't use your calculator to add this. But you are really using your calculator because you're going to do the 3 times 17 with your calculator, aren't you? Which is negative 51 plus, what's 8 times 10? 80. Then you're going to do that with your calculator and get 29 over 24. Cool?
1 and 4 over 24.
1 and 4?
1 5.
Right. 1 and 5 over 24. That is how you guys saw this in your younger days, correct?
Also, we don't need to do that.
That's one way to do it, Tasha. I'm going to show you another way. If you are happy with this, then do this. Do you understand me? Do it this way. This is not elementary and middle school. If you are happy with this, do it this way. But I'm going to show you another way that I find easier. If you don't dig it, don't do it. You with me? You don't even have to write it down. You can just look. Yeah, go now. If you get this, then go now. Okay, now I'm going to show you another way that I think is easier. I'm going to change color and I'm going to work only in blue. So what do I have here? I have negative 2 and 1/8 plus 3 and 1/3. This is the same as -2 plus 3 and -1/8 plus 1/3. Does everybody see that? I had a -2, I still have my -2. I have a -8, I still have my -8. Is everybody okay?
Oh, I get it.
Yeah. Now, what is -2 plus 3? 1. So that equals 1. Cool? Everybody with me?
Are you adding the
No
wholes
way.
and then adding the fractions?
Yeah.
Oh.
Now, what we know our common denominator is 24. So that's -3 plus 8, because I did this, right? -3 plus 8 is 5/24, 1 and 5/24. Do I care as your high school math teacher which of these methods you use?
No.
No. You do what you're comfortable with. Okay? Is everybody happy with that? Now, when you turn the page over, you will see a bunch of blanks. Okay?
Yeah.
But you will also see empty space over here. Do I care which one you use? This way is going to be -1 plus 3 and -5/16 plus 3/8. You all just saw that, right?
No, I wasn't
I
watching.
really hope that got on recording. That was funny.
What happened?
I wrote it all out and then it just disappeared.
Oh, well, you should rewrite it.
Wow. That never would have occurred to me.
Yeah.
Thank goodness. -1 plus 3, -5/16, and +3/8. Now, if you want to do it that way, do it that way. If you want to use improper fractions, work over here. Everybody ready? Go.
Wait, huh? Oh.
Go.
Keep going, go.
On your method. Mm-hmm. I'm going to do both versions, of course. Over here in red. Did I do that right? Oh, I did that wrong. No, I did it right. No, I did. Oh!
Oh, looks like we gotta rewrite it again.
Wait, where'd it go?
It vanished.
It's crazy.
You have video proof of it just disappearing. Or no,
2 and 1/16.
activity.
And over here,
Are you sure?
Don't cry.
Yeah.
I got 2 of them.
so it was -21/16 plus 27/8. Now this had to multiply by 2, correct? Which means that had to multiply by 2, correct? So I had -21 plus 54/16.
I forgot.
21 and that is 33/16. 16 goes into 33 twice to get 32 and 1/16 left over. Now Hayden, you just said
I forgot to do the stuff.
you forgot to do something, right? Because even though you're comfortable with improper fractions, there's actually more steps there. And if you're prone to forgetting a step, the improper fraction way can screw you up a little bit. That's why I choose this way. But again, I don't care how you do it.
It's just that I don't have much space, and I was like messing me up with this all.
Yeah, it's all crammed together. I know. I get it. I'm not angry with you. So, Nick, you need to chill out then, sister. -1 plus 3.
Did you notice that?
Wait, what?
I think there's something wrong with your eraser.
It must be haunted.
It must be like one tap and like everything.
What is this?
Well, I'm gonna rewrite it.
Paranormal math
Like
activity.
draw a bunch of random stuff and
Paranormal
then
math
like
activity.
No, because I've got it set up that my hand is not an input device. Only the pen is an input device.
do what I
Piece of
said.
crap.
It's doing like control Z.
But it's all right, because in August, I get a new one. It says so on the bottom of this, that August 2016, it's when it's dead, and I get a new one. It's only got to last till August.
Doesn't look like
Smash it for August.
Do what I
Why
said.
you got to be that way?
Yeah, why use the store before August and get it?
Why you got to be that way?
Should I
All right,
have it after
we're going to do this last question, and then I'm shutting up.
Then we're free.
19 over.
So, 2 plus 1, 2 plus 1, 3, right? And then I'm going to deal with the fractions. 3/5, 1/4. My common denominator is 20
Yay.
times 4 times 4, 12 over 20 times 5 times 5, 5 over 20. And I get 12 over 20 and 5 over 20. That's 17 over 20, 3 and 17/20ths.
No, that's my thing.
Everybody cool?
It's very loud.
Now, listen. Please, when you look at your outline, you notice I have 2 pages there because it's adding and subtracting. We haven't done subtracting. We haven't done any notes on it. All I want you to do is page 111, and I only want you to do this. I don't want you to do 1 to 20. Just do these questions.
3, 9, 11.
3, 4, 5, 9, 11, 13, and 15. Erlen.
Wait.
I will. I'm going to put it back
Wait,
right
what?
now.
So is page 111 due for homework? Did you
Just those
say that?
questions.
I'm sorry.
Yeah. But just these questions, not 1 to 20.
Okay, but not page 1.
Not 119.
Okay.
Oh, no.
Guys, relax. I'm just going back to the notes. I'm going to put this back up in a second. Holy, chill out.
All of it's gone.
This is gonna be a good recording.
Roasted.
By 2.
No, I didn't.
I know you did.
But we'll never know, will we?
This will be a good recording. I'll just show everything erased and you going.
It's not even that